Ngige, and welcome to Maths with Mesha Ngige. So today we're going to be checking again revision from NEC 2024 past paper, October-November series. And today we're going to be checking on that was question number 1A, right? We're going to be checking question number 1A because we've already checked question number 1B, so you can also check the question using the link provided below. So now we have our question number 1A, and it was saying it was about Newton-Raphson method, and the question said given that xn is an approximation to the root of the equation, so the equation, and write the equation down. So you have the equation is given by x cubed minus x squared plus 3x minus 2 equals to 0. Of that equation, use Newton-Raphson method to show that a better approximation xn plus 1 is given by. So you show that xn plus 1 will be given by 2xn cubed minus xn squared plus 2, then all over 3xn squared minus 2xn, okay, plus 3. So then part 2 says, says taking your first approximation x naught equals to 0.5, determine the root correct to 6 decimal places. All right, now so we just jump right into that. So solution. So Newton-Raphson formula states that for a better approximation xn plus 1 is given by xn minus fxn, then over the derivative, that is the first derivative of xn. So the first thing we do, we have our equation here, so we let our fx first of all to be this function here. So we have x cubed minus x squared plus 3x minus 2. Okay, so we just take this part without the 0 right together. Then from there we now let where every part we have an x, we introduce a subscript n. So this will be xn then cubed. It is the same function, nothing changes right together. You're just introducing a subscript here and n all through. So plus 3xn minus 2. Therefore again we find the first derivative of xn. So drop the power, reduce the power by 1. So we shall have, you drop 3, then xn, this one was cubed, so it becomes what? Squared. Then minus, drop 2, then reduce the power by 1. It was 2, now it becomes 1, so it will remain the same. Then here we shall just have 3, because we have our power is 1. So when you drop 1, you have 3 times 1, which is 3. Then reducing this power by 1, it becomes xn to power 0. And any value to power 0 always gives you a what? Any value to power 0 always gives you 1. So now inputting all the outcomes in this formula, so we shall have xn plus 1 will be given by, our xn is this, minus, now remember we always bracket them, okay? The function fxn, it is this function here. So we have xn cubed minus xn squared plus 3xn minus 2, okay? Then divide by the derivative, and our derivative is this, okay? So 3xn squared minus 2xn plus 3. Right together. So this is the function fxn, then we have the derivative. Okay, now we want to write all these into one fraction. Okay, so we can put this one over 1. So what is the LCM of this term and this term? The LCM will just be this term here, because here is just a 1. Are you together? So in essence we're just saying we'll multiply 1 here and we'll multiply this part in this part here. So we shall have xn, okay, then 3xn squared minus 2xn plus 3, okay, then minus 1 multiplies this. All right, remember we are saying these two, at any case where you're having the terms in the denominator not being the same, the LCM is always the multiplication of the two. So this times this. and this times this just gives us the LCM to be this, because anything times 1 is just the same function. Are we together? So again, since they are not the same, so this part will multiply this this term, and this part will multiply this term. So that is what we just done. This multiply by this multiply by that. So, and all of these times 1 just gives you the same function. So you shall have xn cubed minus xn squared plus 3xn minus 2. Then all of that, okay, over 3xn squared minus 2xn plus what? Plus 3. Alright, then from that point you can open up the bracket. You can now open up this bracket and simplify further. So we shall have, so xn times 3xn squared. So remember, the subscript should not worry you by the end of the day. What you're interested in is the term of x. So we have an x and we have an x. This one is squared, this one is x. So we have what? X cubed, okay? So we'll have 3xn cubed. So equals to, then xn times this. So we shall have minus 2xn. Now your xn becomes what? Squared, because you have this one and you have this. xn times 3. So plus 3xn. So we have that term. Then here we have a negative. So the negative opens all this bracket. That is the reason why I said the bracket is very, very important. So we can close it there. So the negative multiplies everything. So we shall have xn cubed. Okay. Then negative gives you positive. So plus xn squared. Then we have negative positive gives you a negative minus 3xn. Then we have negative gives you a positive. So plus 2. Okay, then all of that over the LCM, which is 3xn squared minus 2xn, then plus what? Plus 3 equals to. Now collect like terms. So collect the terms that are cubic and the ones that are squared, and the one that has a variable xn only, and the one that is constant. So we have 3xn squared cubed, subtract cubed. So we have a cubed here and a cubed. So these ones are 3 and you have 1. So 3 minus 1 gives you 2. So 2xn cubed. Now go to the square part. We have negative 2. Remember, a value carries the sign before it. So negative 2xn squared plus 1. So negative 2 plus 1 gives you negative 1. So it will be negative xn squared. Okay, then we have positive xn, 3xn, negative 3xn. That becomes what? Becomes 0. So we remain with, then so this and this cancels out. So you only remain with what? You remain with 2. So plus 2. Then so therefore all over 3xn squared minus 2xn plus 3. And that is the better approximation, xn plus 1. So have we proven that indeed we have that as the solution? Yes, correct. Because the better approximation here is just what we have just found. Right, together. So that is the first step. Then the second step is now to use our first approximation. Remember, our approximation go on and on from the first, the second, the third, the fourth, up to when you shall find your numbers repeating themselves. And in our case here, they're supposed to repeat themselves after 6 decimal places. So at the point where you shall find that at the 6th decimal place your number is repeating itself, then that will be your value, the approximate value of to the value of x. Are we together? So now our first approximation is x naught is 0.5. Now we go to the second approximation, which is x1. So our x1 now will be given by, so we're in the second part, so we are solving part 2. So this one has already been proven, so you can tick that, so that is true. Now the second part, we have our x naught, which is 0.5. Now we go to x1. So x1 will be given by 2. Take your value, the first approximation, replace it in this equation as the value of xn. Are we together? So therefore, our first approximation was 0.5. Then we have cubed minus 0.5 squared, okay, plus 2, right? Then all over, okay, 3 0.5 squared minus 2 0.5 plus 3. So we can now solve that. So let's have that in a moment. So we have 2 0.5 into bracket to power 3. Then we have minus into bracket 0.5 bracket, then we put it squared, then we have plus 2. So the numerator gives us 2 as the solution. Then denominator, we have 3 into bracket 0.5 squared minus 2 0.5 plus 3. So it gives you 2.75. So 2 divided by the answer will give us 0.72727. Now, until the last answer to the 6 decimal places, kindly your answers should be around 7 decimal places. So you always put your answers into an extra decimal place in such a way that by any chance you get a number that when you round off to the 6th decimal place, it gives you the number that you had previously, then that will be a solution. So in our case here, it is 0.2722727 and so on and so forth. Now this number is what now you replace. So your x2 will be given by 2. Now replace this number. So 0.72727. So these are 7 cubed minus 0.727272. Then you have 7 squared plus 2. Okay, all over 3 0.7272727 squared minus 2 0.7272727, then plus 3. So we can now find our values, and you have 2 into bracket 0.7272727 bracket, then I cube that, then minus into bracket 0.7272727 into bracket squared, then plus 2. It will give us 2.240420. Then you can have 7. Then all over. So the denominator is 3 into bracket 0.7272727 into bracket squared minus 2 into bracket 7272727 into bracket plus 3. That gives us 3.112457. Then you have 6. So when you have that, so 2.2404207 divided by the answer, we get our answer to be 0.719. Let me write it here so that you can it will be visible. So our solution here will be 0.7198 237. Okay, so you can see I'm putting my numbers in 7 decimal place. Now let's go to x3. So we have again 2. Now we'll use this number in the next approximation. So 0.719. Okay, 7198237. Then you cube it minus 0.7198237. You square it plus 2 all over 3 into bracket 0.7198237 squared minus 2 0.7198237, then plus 3. So you can have your value. So you have again 2 into bracket 0.7198.237 into bracket cubed, then minus into bracket 0.7198.237 into bracket squared plus 2. That should be 2.2278016 divide by. Okay, now you have the denominator, which is 3 into bracket 0.7198.237 into bracket squared minus 2, then 0.7198.237 into bracket and plus 3 gives you 3.1147911. Okay, to 7 decimal places. Then this one I can just write the solution there. You shall have, or just rubbed it, 2278016 divide by 3.1147911, and you get your answer will be 71523. Then I can just put a 1 there. Okay, 7 decimal place. Now let's check our x4. Maybe we might be lucky to get our answer there. So we shall have 0.71523331 cubed minus 0.71523331 squared, then plus 2 all over 3 0.71523331 squared minus 2 0.71 okay 52331 then plus 3. So let's see what that gives us. So we have 2 into bracket 0.7152331 into bracket cubed, so you cube that, then minus 0.7152331, then you square that, then plus 2, and that gives us 2.22086. Okay, 22020. Yeah, we have that. Then all over 3 into bracket to bracket 0.7152331, then you square that, minus 2 into bracket 0.715 okay 2331 into bracket plus 3. Okay, that gives us 3.104 208, so 209. Sorry for that. 209 90. Yeah, so you can have that. So therefore divide that, so 2.220208.6 divided by answer, and we get that our answer is 0.7152252. So therefore it means we are still into 6 decimal places. If you check the numbers, so here we had 1, 2, 3 numbers, Now these numbers have been repeated, so we have around 4 of them already which have been repeated. Now let's check the last one. Let's check our x5 to see if it gives us the solution to that. So our x5 therefore will be, so our x5 we shall have into brackets, so we shall have 2, our 2 there, then 0 point, so our number is 7152.5, 6, then 2. Okay, then we have that one which gives us what? Cubed minus 0.7152252, then we have squared plus 2, then all over 3, 0.7152252, then we have squared minus 2, 0.7152252, then plus what? Plus 3. So let's see, that one now gives us an answer. So we have that 0.7152, then 22, then 52 into bracket, then you cubic, then minus into bracket 0.7152252 into bracket, you square it, then plus 2. That one gives us 2.220195.6. Okay, then all over 3 into bracket 0.71522 71522, then we have 52 into bracket squared minus 2, 0.71522, then 52, then into bracket, then plus 3. So that one gives us 3.1041909. Okay, so dividing the two, so we have 2.2201956 divided by answer. We get our solution will be 0.71522252. Ladies and gentlemen, students, if we check our answer here in the fourth approximation and the answer that we have here in 6 decimal places. So in our 6 decimal place here we shall have 0.715225. And what did we have here as this approximation in 6 decimal places? 0.15225. So therefore your better approximation or your value for x will be given by the root, that is the root will be given by 0.715225, and that one, students, gains you 11 marks in your final exam. So that is it for Newton RAPHSON October November 2024 series.